Welcome back to the GCSEMathsPro YouTube channel. Today's video is on the Paper 1 Higher Tier Edexcel November 2023. So this is a non-calculator paper, and so therefore we're just going to go through it without any calculators at all. Make sure you do it without your calculator, because otherwise you might feel like if you're using the calculator you can do it quite well, and then when you get to the exam you might not be used to not using the calculator, right? You might not realize the certain types of calculations that you can't necessarily remember how to do without a calculator. So do make sure you're doing this without a calculator, just yourself. So let's get straight into question 1. We've got another decimal multiplication one. I don't know if you remember, we did one last week, June 2023, paper 1, which I'm pretty sure the first question was very similar. We had some kind of decimals multiplied. So definitely make sure you know how to do this. We need to work out 6.3 times 2.4. So obviously there's different ways to do it. The way that I like to do it is just make them both whole numbers. So in this case, you see how I'd multiply them both by 10. So I'd make it like 63 multiplied by 24. And then I like to use column multiplication personally. And then at the end, we'll put the decimal back in the scale to make sure it's right. So column multiplication, again, hopefully you remember how to do this. Starting with the 4, multiply by 3, which is 12. So obviously the 2 will go below, and I'm carrying a 1, because 1 is obviously bigger than 10. Then we've got 4 times 6, which is 24, plus the 1, so that'd be 25. So obviously the 5 would go here. You'd carry the 2, which we can just kind of place because that's the last thing we're going to multiply, isn't it? Then for the 20, because this is not just a 2, it's a 20, I have to put a 0 here to make that scale correct. So then I do 2 times 3, which is 6, and 2 times 6, which is 12. So the 2, and then obviously you technically carry the 1, so you just put it straight here. Draw that again. There. And then you want to add those two together. Okay, so going from right to left, obviously 2, this is 11, so again carrying a 1. Then we've got 4 plus 1, which is 5, and then obviously just that 1 there. Now, I've multiplied it, but remember that we did actually change the scale originally. So obviously 6.3 times 2.4 is not 1,512. So you just have to put the scale back in. Now there's two ways to do this. Either you just count how many times you changed the original decimal places. Do you see how I changed that once, and then this one as well once, so that's twice. So then I can change this by 1, 2, 15.12. Or just think about, well, what's 6 times 2? 12. It's got to be somewhere around that scale, hasn't it? You see how 15 is like similar scale to 12, not 1.5, not 150, not 1,500. So your answer is 15.12. Okay, and the marks for that, 3 marks. Question 2, we've got it split now for indices. So write down the value of 5 to the power of 0. Now this one I feel like almost always comes up. Not necessarily 5, but I mean the power of 0. It could be anything to the power of 0. We have to remember that the answer is always 1. Not 0, not 5 itself, it's always 1. Doesn't matter what it is, as long as it's to the power of 0, you should get 1. So it's kind of a trick question, so I feel like naturally you kind of want to put 0. But it's not. It's 1. So just make sure you know that, because I feel like that does come up a lot and it's an easy mark to get. Part II, we've got write down the value of 5 to the power of minus 2, so we just need to know what negative powers do. So the negative power is the reciprocal. Now, the reciprocal is where you flip the fraction upside down, or if in this case 5 is obviously a whole number, you put 1 over. The reason being because 5 originally is 5 over 1. That would be the same as 5, isn't it? 5 divided by 1 is 5. So the reciprocal is 1 over 5, but we also have this 2. So that's the negative bit we've done, but then it's squared. So that would be 1 over 25. Obviously the 1 is also squared technically, but that is still 1, isn't it? Then part B, write 2 to the power of 5 times 2 to the power of 4 over 2 cubed in the form 2 to the power of n, where n is an integer. So we basically just need to simplify this using index laws. So multiplying across, we actually add the powers when they have the same base number. So that would be 5 plus 4. So that's 2 to the power of 9. over 2 to the power 3. Now I feel like they've probably chosen these numbers deliberately. It's kind of a trick question because then obviously the fraction means divide, and I feel like naturally you want to do 9 divided by 3 because that does actually give you a whole number, an integer as they've said, but it's not. When you have a divide symbol or a fraction, you actually subtract the powers. So a bit of a trick question there. It should be 2 to the power 6 your answer. Okay, question 3, another very common question to come up. Write 156 as a product of its prime factors. So that's like the factor tree, isn't it? So you can split it into factors. Now, I like to do it with just using, I'm just going to divide by prime factors initially. Some people just divide by whatever factors they can find and then make them prime. I like to just stick with prime factors. Mostly because I just choose kind of 2, 3, or 5. That's kind of an easy starting point. So normally I see, if it's even, I'll just start with 2 and just keep halving until it's not even anymore. So half of 156 is 78. That's still even, so I can half it again, which gives me 39. Now this is no longer even, so now I'm thinking, okay, does 3 go into it, or 5? In this case, 3 does 13 times, which 13 itself is also obviously prime. So there are my answers there. I'm going to do 2 times 2 times 3 times 13. You could write that as 2 squared if you want. Doesn't really matter. They haven't specified how they want it. Now there is a part B that relates, I think, to this part A. Find the highest common factor of 156 and 130. So we need the product of prime factors for 156, which we've got. And we also need 130, so I'm going to quickly do that. Another tree for 130. This one, I'm just going to start with 2. That should be 65. Now it's odd, so you can see that 5 obviously goes into that. And that actually goes in 13 times. So if I mark my list next to this one, for 130, we've got 2 times 5 times 13. And the way that I like to work out highest common factor or lowest common multiple is with the Venn diagram. So draw yourself some circles. They don't have to obviously be accurate. So 2 circles overlapping, obviously one side will be for the 156, one side will be 130. And we write first of all what overlaps, what do they have in common? Do you see how they both have a pair of 2's there? So 2, you can cross that off. Obviously don't necessarily cross it off on your answer, but you can just see it there visually. I've crossed them off. They also have a 13 in common. That's the only thing they have in common, isn't it? Technically, if you were to fill out the rest of it, you'd have a 2 and a 3 on the left and a 5 on the right. And for highest common factor, it's just the overlap. So if you only just want to fill out the overlap, that's fine. It's just the overlap multiplied together. Okay? So I'm now going to multiply, obviously, 2 and 13, which is 26. If you wanted to know lowest common multiple, it's all of these numbers in the Venn diagram. So 2 times 3 times 2 times 13 times 5. It would be all of those. Okay, sometimes they ask for both. Question 4. The mean length of 5 sticks is 4.2 centimeters. Noel measured the length of one of the sticks as 7 centimeters. Work out the mean length of the other 4 sticks. Okay, so this is what I would call reversing the mean, as in we kind of want to go backwards to undo it, because they've given us the mean already as an answer. We need to go backwards to change something. So think about how you normally work out the mean. You normally, for example, for the 5 sticks, you would take all 5 numbers, all 5 lengths, you'd add them together. So you'd get the total lengths, wouldn't you? Total 5 lengths, let me write that out. Over, and you would divide that by 5, because there's 5 of them, isn't there? And you see how that equals 4.2 if you set up this kind of equation. So when I say reverse, I want to, obviously I can't work out individually what all the 5 sticks were, right? Because they could have been anything. I can't individually pick them out, but that's fine. I could work out the total of them. So I'm going to multiply by 5. Think about how equations work. Multiply by 5, move that across. That would leave me with just that total, wouldn't it? Total 5, I'm going to write. So 4.2 times 5. The way I times by 5 is I just times by 10 and then half it. So that would be 42 divided by 2, which is 21. So the whole of the 5 sticks would add up to 21, is what we're saying. And then they said we measured one length of the sticks as 7. Work out the mean length of the other 4. So we need to take away this number 7, don't we? So from the total, I can take away 7 to get rid of that other stick that they told us about, which gives me obviously 14. That would be the total of the other 4, wouldn't it? Total 4. And it said work out the mean length of the other 4 sticks. Well, again, I don't need to know what they are individually. I just need to know what they add up to, so 14. And then I would then divide that by 4 to get the mean for just 4 of them. So we need to divide 14 by 4. You can obviously do bus stop division for this, or dividing by 4, you can just half it and half again, depends what you prefer. So half of 14 is obviously 7. If you were to simplify this fraction, you'd get 7 over 2, wouldn't you? And then half of 7 is 3.5. So however you want to work it out, that's fine. So 3.5 would be the mean of 4 of them. Okay, so what I mean by reversing the mean is I've kind of undone this equation. Instead of dividing, I've then multiplied to unpick it. So that's part A. Part B is then saying Noel made a mistake. The stick was not 7 centimeters long. So, because originally he said he measured it as 7, he's actually made a mistake. It's not actually 7, it was 17. How would that affect your answer to part A? So, think about the calculations we've done. We did 21 minus 7, didn't we? Well, imagine doing 21 minus 17 instead. You could actually work it out if you want, but it's only 1 mark, so I probably wouldn't. 21 minus 17 would obviously give you a much smaller total. And if you were then to divide it, obviously still by 4, the mean would be much smaller, wouldn't it? So any version of saying the mean would be smaller, the mean would be less, it would be a lower mean, you know, some kind of version of that. Mean would be smaller for the other 4, because that's what we were working out in part A. Some version of that is fine. Okay, question 5, we've got some construction here. So the point P lies on the line AB. Use ruler and compasses to construct an angle of 90 degrees at P. You must show all your construction lines, so don't rub anything out. Okay, so use a ruler and get your compass. Now, I don't have a compass on here digitally, so I'll try my best to kind of demonstrate it to you. It's effectively a perpendicular bisector is what they call it, because 90 degrees is perpendicular, isn't it? I want a straight line perpendicular here at P. Now, the issue is that you see how A and B are not the same distance from P? That's kind of the main issue. So we need to create that same distance. So what I would do with your ruler, because I told you to use a ruler, is I would measure the distance between A and P. And then that same distance I would measure from P, let's say it's about, probably a bit further, isn't it? About here. That same distance and mark it there. So instead of using point B, I'm going to use the equal distance between A and P, and then P and this other dot. Okay, so that's obviously rough on my one, but measure that. And then you're just doing the perpendicular bisector, which is obviously one of the constructions you have to memorize. So from there, what we're going to do is get our compass. Normally I would say measure your compass. It doesn't have to be accurate, but it has to just be, let's say if you put the point on A, the compass has to be longer or wider than point P, doesn't it? So somewhere between point P and your other dot. Maybe about 2/3 of this whole section, I guess. Roughly, it doesn't really matter, as long as it's beyond point P when you've put it on your point on A. So let's say I've got my compass, I've put the point on A, and I've made it wider than point P. Then I'm going to draw like an arc. So obviously mine's going to be rough, but imagine that you can draw an arc with your pencil, something like this. Yours will obviously look a lot better. Then you're going to take the exact same compass. Don't change the width of it. Don't change the distance at all. Flip it round. Put your point over here now, the one where we identified. Okay, put it over here. And then draw the same arc, but obviously in the other direction. So let's try and draw something. So something like this, okay? And then you can get your ruler and join up. You see the 2 points. up here where they cross over, and down here. Now mine obviously doesn't cross over accurately because I obviously haven't used a compass, but yours should, as long as you've measured the distances correctly for A and P and then P and the other dot. So where is my line? Get a straight line. You would join them up. Now, as you can see, obviously mine, I mean, it should go through point P. Mine's way off, obviously. Yours should look something like that. Let me see if I can adjust what I've drawn. Oh, that's the whole thing. There, let's see if I did that. Okay, that's basically what yours should look like. Okay, obviously a much smoother line than mine. So when they say don't rub out any construction lines, just keep obviously all of these kind of arcs and everything in there. Don't rub anything out. They need to see how you worked it out. But that's literally it. Okay, so it needs to be equal distance from A and P in the other dot, and then just two curves, two arcs. Okay, question 6. The diagram shows an isosceles triangle ABD and the straight line ABC. Okay, so isosceles here, which you can see with these two dashed lines there, that tells you that they're equal sides, and then a straight line. Yep, they've told us which two are obviously the same, BD and BA. They've said X to Y is 2 to 1, and we need to work out the value of W. So just some general angles question here. So with an isosceles triangle, we should know which two angles are the same, based on obviously which two sides are the same. So because these two sides are the same, angle D and angle A are the same, aren't they? So that would also be X. Now, I obviously know that a triangle adds up to 180, but having two letters, X and Y, doesn't really help because I can only create, I've only got information enough for 180 degrees means a whole triangle, doesn't it? So I need one equation, I need one letter. So what I mean by that is I'm going to use this ratio right now to convert Y into X. Okay. So X is 2, Y is 1. So you see how this one, Y is obviously half of X, isn't it? Is what we're saying. So if that's X, and in terms of X, this would be a half X, wouldn't it? That's one way of doing it. That's one way. So you could write here instead half X. And then I can create my equation that all of those should add up to 180, shouldn't they? So we're X plus the other X, which is the same angle, plus the half X, which is where Y was, equals 180. You could do that. The other way that you could do it is just by setting up the ratio into a 3-part ratio for each of the corners if you wanted, each of the angles. X to Y, we've obviously got 2 to 1. There's also another X now, isn't there? Which is therefore another 2. So you could use a 3-part ratio and split 180 into the 3 parts if you wanted. Up to you. A lot of these have 2 different ways to do them. So if I carry on with this equation here, obviously if I collect the like terms, add them up, do you see how that would be 2.5x is 180. Now this one you might go, well, actually I'd rather not divide by 2.5, which is fair. You could double it first if you wanted to make 2.5 a whole number, or times it by 10. So let's say we could double it to make it 5x and 360. Dividing 360 by 5 is a little bit nicer than 180 by 2.5, but you would get the same answer. So however you want to divide it, could be bus stop, you could just do the same as we said about timesing and dividing by 5. Dividing by 5 is the same as dividing by 10 and then doubling your answer. So if I divide by 10, do you see how that would be 36? And then if I double it, it would be 72. Or you could use bus stop division, that would also work. So x is 72 degrees. Do you see how then we could work out what y was? I kind of rub this out now. We've got 180 minus 2 lots of x, or obviously we said that y is half of x, so you could just divide that by 2. Dividing 72 by 2 is 36. That's a more direct way of doing it. Now I know what y is. Zoom back up so you can see the actual image. Y and w are just on a straight line, aren't they? So obviously we know that angles on a straight line add up to 180. So all I need to do, my last step, is 180 minus y, which is 36. So w is 180 minus 36. Yeah, you could do column subtraction, or you could just take away 30, take away 6. If I take away 30, I get 150. If I take away 6, I get 144. So w is 144. There, 4 marks. Okay, question 7. Mano has 3 shelves of books. There are x books on shelf A, there are 3x plus 1 books on shelf B, and there are 2x minus 5 books on shelf C. There is a total of 44 books on the 3 shelves, so that's already telling me there's an equation there. All of the books have the same mass. The books on shelf B have a total mass of 7,500 grams. Work out the total mass of the books on shelf A. So that's telling me I need to work out, first of all, what x is to know how many books I have on each of the shelves. So I can use the information at the top to create an equation. Obviously, the total of the books is 44. So if I add up all of those, x for shelf A, 3x plus 1 for shelf B, and 2x minus 5 for shelf C, that should add up to 44, shouldn't it? You see how that's just an equation now? So if I add all of those, if I collect the like terms, we should get, what's that, 5x, 6x minus 4 is 44, and then that's just a linear equation to solve, so add the 4, 48, divide by 6 is 8. So x is 8 books. So that's that first bit. Let's look at the next bit. The books on shelf B have a total mass of 7,500 grams. Okay, so I want to know how many books that represents. So that was a 3x plus 1, wasn't it? So let's substitute x into 3x plus 1. So 3 times 8 plus 1 is 24, 25, isn't it? 25 books. That's shelf B, isn't it? So I've got 25 books on shelf B, and they add up, the weight or the mass of them is 7,500 grams. So I want to know how much one book weighs. So I'm going to have to divide that, aren't I? 7,500 divided by 25. Hopefully you can see they've chosen some quite nice numbers here. You can use bus stop again if you like. You can just simplify the fraction, however you want to do it. But I know that 25 goes, if you ignore the zeros for now, 25 goes into 75 3 times. So then just add 2 zeros. So each book weighs 300 grams. And then we wanted to work out the total mass of the books on shelf A, which shelf A, I don't know if you can remember that, if you can have a look on your own paper. Shelf A is X books, which X is 8. So my last step is to go, well, each book represents 300 grams, and there's 8 books on shelf A. So 8 times 300. Again, I'm going to multiply this by just ignoring the zeros for now. 8 times 3 is 24. And then obviously put the zeros back on. So 2,400 grams would be the weight or the mass of shelf A. So that's just kind of general arithmetic there, some general calculations. Question 8. The normal price of a mattress is reduced by 40% in the sale. The price of the mattress in the sale is £660. Work out the normal price of the mattress. Now I feel like we had one of these last week as well. I don't know if it was calculator or non-calculator, but we had something very similar. This is reverse percentages because we need to kind of go backwards in time from the sale that's now to what was the original price. So first of all, we need to check out what percentages 660 is equal to. So you've got £660. What is that equal to? Now, it's the original price, the normal price, whatever is in the past, is always the 100% because that's your starting point, isn't it? They've then reduced that by 40%. They've taken away 40%. So do you see how much would actually be left? There would only be 60% left, wouldn't it? So it's not that 40% equals 660. It's that 60% of the original price is the same thing as the £660. I need to kind of create that, not really equation, but just understanding, don't I? I need to understand that that's what's going on. Because if I want to find the normal price is 100%. So because this is non-calculator, I need to kind of go, well, I like to compare it like this vertically. How would I go from 60 to 100? There's loads of different ways. You could divide by 6 to get 10%, divide this whole one at the top by 6 to get 10%, and then times by 10 to get 100%. You could divide by 3 to get 20%, times it by 5. You know, there's loads of different ways to do it. I think maybe this one, let's divide by 6. A lot of people think, oh, I need to divide this one by 10 to get 10%. But that would be 10% of the sale price, not 10% of the original, so it wouldn't work. So I'm going to divide both sides by 6. I guess you can imagine it's an equation like this. So we'll leave our 100% for now. Divide both sides by 6. You see how obviously 60% divided by 6 is 10. And then 660 divided by 6, hopefully that one you could see, is 110. Obviously, if you need to do bus stop, feel free to do that. Then to get 100%, so the original price, the normal price, I would obviously say, well, how do I go from 10 to 100? We have to times by 10. So just add a 0 basically. So that's £1,100 is the original price. If this was a calculator one, I would do it more directly and I would do that price, the sale price, divided by what percentage it is as a decimal. That would give you the answer directly. Obviously, I probably wouldn't want to do that non-calculator myself. I would rather do it this way. So you've got the two options depending on if it's a calculator question or not. Okay, question 9. So to cook rice, they've said the number of cups of rice, which is X, to the number of cups of water, which is Y, is 4 to 5. So I like to kind of write the letters above just to reference it quickly. So use this information to draw a graph to show the relationship between the number of cups of rice and the number of cups of water needed to cook the rice. So this is a linear relationship, as in a straight line. Because every time you have 4 cups of rice, you're going to need 5 cups of water. So every multiple of that would be, it would create a straight line, wouldn't it? It's a linear relationship. So what we need to do is, first of all, I mean, you could create the equation. They've obviously not given you space to do that. But what I'm thinking is, I just think we need to create 2 sets of coordinates, don't we? When we're trying to plot a straight line, unless they ask you to fill out a whole table of values, you only need 2 sets of coordinates because then you can just get your ruler and join them up, can't you? So I normally start with like, what's the y-intercept? So let's say if x, or the rice, the number of cups of rice is 0, how many cups of water would I need? Well, if I've got no cups of rice, then I would technically need no cups of water, wouldn't I? So that's obviously starting here at 0, 0. Then the other easiest one is to go 4, 5, as in if I need 4 cups of rice, then that's based on my ratio, I need 5 cups of water, don't I? And then I would just join this up. Obviously extend your line straight through. But you could think about it, if I need 8 cups of rice, that would obviously therefore be 10 cups of water, wouldn't it? So you could plot that as well if you wanted. See how that creates a straight line? And then I just join up. So linear relationship. Obviously the gradient is positive because the more cups of rice I have, the more cups of water I need. So that's literally part A there. Part B, I, is find the gradient of the line drawn. Well, if you weren't sure if it was a straight line, they've also said here that it needs to be a line, and obviously for finding the gradient, it's normally just because it's a straight line, isn't it? So that's kind of a clue if you weren't sure about part A. So all this is asking is find the gradient of the line, of a straight line. You can obviously use the ratio to work it out, but I'm just going to keep it kind of within what you know about straight line graphs. The gradient of a line is change in y over change in x. So I would choose, again, just choose the 2 coordinates that you plotted. I'd probably choose this and the 0, 1 because that's easier. So y goes at the top, so 5 minus 0 over 4 minus 0, which is obviously just 5 over 4, literally. So you can write it like that. You can put it as a decimal if you prefer, but I would probably just leave it as a fraction. That's the gradient. In other words, it's 1.25. And then it says, explain what this gradient represents. Now, this is the one where you have to kind of relate it to the context. So the way that I would write it is, do it always based in the x-axis. So for every cup of rice, that's the x-axis in this case, isn't it? Of rice, you have to add, where's my A? Add 5 over 4 cups. Or you can write 1.25. That's the same thing, isn't it? Of water. So it's like when they ask this question, it's for every 1 unit of the x-axis, which is in this case a cup. For every cup of rice, you need to add, and then whatever the gradient is in terms of the y-axis, which was cups of water. Okay, that's all it's asking. It just wants you to relate the gradient to the actual context of the graph. Okay, question 10. The circumference of a circle is 10 meters. Work out the area of the circle and obviously give your answer in terms of pi because it's non-calculator. So we need to know 2 formulas here. The circumference, which you either know it as pi times diameter or 2 pi r, doesn't really matter, whichever you prefer. And then the area, which is pi r squared in all cases, really. Pi r squared. So that's what we're going to need to do. We're going to start off with the circumference because that's what they've given us to start with, basically, isn't it? So I'm going to put, I might use 2 pi r in this case. I normally use pi d, that's just my choice, but I feel like I might use 2 pi r in this case just because we're going to use the radius again. But you can use both, it doesn't really matter. So 2 pi r is equal, create an equation, is equal to 10. Now, in order to work out the area, I need to know the radius, don't I? Or at least an expression for the radius. So that's what I'm going to do. I'm going to solve this equation to get r as the subject. So what I need to do is just divide across by 2 pi. So 10 over 2 pi. Obviously, I'm not going to get you to work out pi, right? They've said just leave the pi there. But the 2 I could work out, couldn't I? See how that fraction would simplify to 5 over pi, because 10 divided by 2 is 5. So that's the most simplified version of, what's this in meters, of the radius. Now, if you did pi d, work out the diameter, and then just remember at the end you'd have to half that answer. Okay, so just consider that. Then we can now go on to the area, actually working out what we want to know. We want to know the area. So the area is pi, and then the radius squared, which here I've got as 5 over pi, and then all of that squared. So I'm going to kind of expand and simplify this. Leave the first pi there for now. Squaring a fraction, you just square both numbers, so obviously the top would be 25. The bottom, I would just write it as literally pi squared. You don't need to actually work out pi squared. And then we're multiplying. I'm going to multiply the pi on the outside by the fraction. Now, take the pi as, obviously pi doesn't represent a whole number, but as in, to create it into a fraction, you just put it over 1. You do that with all numbers as well. So I would just multiply across. You see how that would give me 25 pi at the top, and then just pi squared at the bottom? And now I can simplify that fraction. See how I've got a pi at the top and then pi squared at the bottom? So I could cancel out the pi at the top and the other pi at the bottom. So my answer would be 25 over pi. You don't need to work out the pi, right? They've just said leave it in terms of pi. Literally, that would just be your answer. Okay, so they won't ever make you work out actual values for pi unless they say estimate, in which case just use the number 3. Okay, question 11. Alice recorded the number of cars going into a village on each of 80 days. The incomplete table and the incomplete box plot give information about her results. So part A, I don't know if you can see that there, part A is use the information in the table to complete the box plot, and then after that use the information in the box plot to complete the table. So a box plot has 5 vertical lines. As you can see, they've currently drawn 2 of them. And in this list here, we've got, the least number, the lower quartile, the median, upper quartile. The only one we're missing is this would normally be the greatest number or the maximum, wouldn't it? They've given us the range instead. So those 5 things you need to know: least, lower quartile, medium, upper quartile, max, or greatest. So we need to draw on the box plot. They've obviously drawn the lower quartile and the upper quartile. We need to draw then on the medium. The reason why I know this isn't the median is because obviously the medium is 900, which is somewhere inside the box, isn't it? So they haven't drawn the median. So let's draw that. So just be careful of the scale. 800 is there, 1000 is there. So 900 is obviously this middle line here, isn't it? So just draw a line there. That's our median. Then we need the minimum and the maximum, or the least and the maximum, the greatest, whatever you want to call it. The least number is 300. So come here. 300 is halfway between obviously 200 and 400. And then that's like a tail, isn't it? Or like a whisker. So draw a straight line across. Now we need the greatest number, or the maximum number. They haven't actually literally given it to us, have they? As in, they haven't listed it there. But they have told us the range. So what we need to know is that the range is the difference between the least and the greatest. So I actually just need to work that out. That would be the least plus the range is obviously the greatest then, isn't it? So you might have to work that out. Just double check what they've given you on your table. They might give it to you straightforward, or they might give you different ranges that you have to calculate. So do you see how the greatest or the maximum would actually be 1300? Obviously it has to be bigger than the upper quartile, this 1200, so we know that that makes sense. So plot that on. So and obviously make a tail kind of whisker thing there. So that's part AI. We've actually completed the box plot, but now we need to complete the table. So the only thing missing is the lower quartile and the upper quartile, which, if you're happy with box plots, you'll know is this one here and this one here. So we just need to read those off. Now, the upper quartile is a bit more obvious, isn't it? It's on an actual solid line. So that's 1200. That one's quite easy. The lower quartile, we just need to be careful we know what the scale is. So this is 700. And then do you see how there's 5 squares between 700 and 800? So each of those squares must represent 20. 20, 40, 60, 80. So that's 780. So just be really careful you've read that off correctly. The lower quartile is 780. Okay, so that's part A. Let's scroll down. We now have part B. On some of these 80 days, Alice saw fewer than 1,200 cars going into the village. Work out an estimate for the number of days Alice saw fewer than 1,200 cars going into the village. So that's a key number there. They've chosen that deliberately because you see how if we refer back here or to the table, that was the upper quartile, wasn't it? And you should know that the upper quartile, either know it as 75% or as 3/4, whatever you want to do. Same thing. As long as you know that the upper quartile is 75%, or 3/4 of all of the numbers, in this case of all the days, then we can work it out. What we need to do is take 80 and just work out 75%. So that's however you, or 3/4, however you want to work it out. You might work out, because this is obviously non-calculation, you might work out 10% times by 7, blah, blah, blah. Or I feel like 3/4 is easier, isn't it? You just need to take 80, divide it by 4, so that's 20, which would be the same as like 1/4, and then 20 times by 3 is 60, which is 3/4, which is the same as 75%. So however you want to work that out, it doesn't really matter how you work it out, as long as you get 60 as your answer. They've deliberately chosen 1,200. Now, based on that, just so you know, the median is obviously 50% and the lower quartile is obviously 25%. So you just have to know those markers. Okay, question 12. The straight line L has equation 2y equals 3x minus 7. Find an equation of the straight line perpendicular to L that passes through 6 minus 5. So this is a really nice question. Really, really straightforward. They haven't asked it in any weird way. They haven't come from a different angle. It's just straightforward. Work out the equation of a perpendicular line. So equation of any straight line, y equals mx plus 3 plus c. That's our basis. That's our foundation. And that tells you I need to know m and c. M is the gradient, c is the y-intercept. I need to know m first. I need to know the gradient first. Gradient. Oh. What happened there? And c is the y-intercept where it crosses the y-axis. So I always work out the gradient first of any straight line because I need to know that to help me find the y-intercept. So the gradient, again, before we saw change in y over change in x. We can't do that here because we don't have two sets of coordinates. We've only got one. So the other way to do it is obviously based on this information that the other line is perpendicular. So I need to look at the gradient of the original line. It's not 3 because you see how we've got 2y. It has to be 1y in terms of y. So what I need to do first is just basically rearrange that equation, make y the actual subject. So that just means halving everything, doesn't it? So that's L, that's the original line. Y would be 3 divided by 2 is obviously 3 over 2. I would leave it as a fraction just for this purpose. Minus 7 over 2. The y-intercept of the other line doesn't really matter, but technically that's correct. So the gradient of the line, if I put it as L, is 3 over 2. And if I put the gradient, I'll put P for perpendicular, right? For our line that we want. This is where you have to remember perpendicular means negative reciprocal. There's two things there that we have to change. The first is negative. Now, if it's not negative, you make it negative. If it's already negative, you make it positive, okay? So you swap the symbol, basically. And then reciprocal, we mentioned before, is where you flip a fraction upside down. So that's why I didn't write it as 1.5. I left it as a fraction, because then it's easy for me to just flip. So the gradient of my line, which is perpendicular, is negative 2/3. Once you've got that, you can write out the y equals mx plus c, but obviously now we know m is negative 2/3. So you can kind of tick off that information. We've used that information. Now I'm just left with the coordinates I haven't used. When we find the y-intercept of any straight line, you just need to know a set of coordinates that are on the line, which we know is 6 minus 5. So substitute those in. Just be careful you put it the right way around, because obviously it's quite easy to put 6 first and then minus 5 second when it's actually not that way around, is it? Minus 5 first, minus 2/3 times 6 plus c. Do you see how now I've got an equation with only c? So I can solve that. So we obviously need to be happy with multiplying fractions and everything, being non-calculator. It's going to be negative overall. You might know that 2/3 of 6 is 4. You could just do that straight away. If not, a whole number, so 6, you multiply just by the numerator. So that would technically be 12 over 3, which, as we just said, would give you 4. That's minus 4 plus c, and then obviously add 4, so that's minus 1. Once you found out those two bits, the m and the c, you just have to write the whole answer, don't you? So y equals minus 2/3 x minus 1. That would be the equation of that straight line. Okay, question 13. So question 13, solid A and solid B are similar. The ratio of the height of solid A to the height of solid B is 2 to 5. The volume of solid A is 12 centimeters cubed. We need to work out the volume of solid B. So this is that topic where it's kind of sometimes volume, sometimes surface area, ratios, all of that kind of thing. And they haven't actually specified what type of shape it is. So we're not going to use any like actual equations or anything. We just need to use the fact that they're similar. This is actually quite easy to do once you know what to do, but it's very hard to figure out if you don't know what to do. So think of this, the height. In this context, the height, well, height is always one-dimensional, isn't it? It's always one-dimensional. So I always think of these as like 1D, 2D, which is area or surface area, 3D, which is volume. Always think of it like that. Think of the units. This is cubed, isn't it? The height would be in terms of just centimeters, which is technically to the power of 1, but obviously don't normally write that down, do we? So what I like to do is, what we need to do is find a ratio for the volume of A and B. That's what we need to do first, and then we'll use the actual number 12. So I always write it down like one dimension, which in this case is the height. A to B, we know, is 2 to 5. To find out the volume, which is 3D, you have to oversimplify it. We're not using any formulas because we don't know what kind of shape it is. You're just going to cube it. If you're starting with, obviously, the one dimension, you're just going to cube it. So 2 cubed is 8. 5 cubed is 125. So that's the ratio for the volume. You literally just cube it. If it said surface area, you would square it because area is squared, isn't it? Centimeter squared, 2D. And then all we need to do is go, well, okay, what was the actual number of the volume? The actual volume was 12, wasn't it? So compare those, ignore the 2 and 5 now. Do you see how now we're just looking at, I've got a ratio, I've got one side, I just need to work out the other. That's all we need to do. So this one's not necessarily ideal in terms of the numbers they've chosen, because you go, well, how do I go from 8 to 12? It's actually times in by 1.5, which is kind of annoying. So you could obviously work out like that. 12 over 8 simplifies to 3 over 2, which is 1.5. The scale factor is I need to multiply by 3 over 2, so I would also have to multiply 125 by 3 over 2, or by 1.5. So 125 times by 3 over 2 is the same, right, like that, is the same thing as dividing it by 2, so halving it, and then timesing by 3. So half, this is why I say it's not ideal, because you're going to get a decimal. Half of 125, if you half it, like 120 is 60, isn't it? And then 5 is 2.5, so that's 62.5. That's the same as 62.5 times 3, which you could multiply, or you could just add it up 3 times. It's up to you how you want to work that out. So obviously 60 times 3 is 180, plus 2 times 3 is 6, plus 0.5 times 3 is 1.5. However you want to work it out, it doesn't really matter. But we should end up with 187.5. Oh, no, that's not where the point goes. And that would be this side of it, which is therefore the answer. So they've kind of chosen some tricky numbers there. It's kind of annoying, but hopefully you could work that out, 187.5. But the point is, if you get this type of question, just think of it as, have I got 1D, 2D, 3D? Do I need to square? Do I need to cube? Or if we're going backwards, do I need to cube root? Do I need to square root? All of that kind of thing. It's kind of oversimplified. Okay, question 14. This is a nice one if you've memorized how to do fractional indices and negative indices. Work out the value of 27 to the power of 2/3 plus a half to the power of -3. So this should be really easy. Just memorize exactly what to do. So fractional powers, we start off with the denominator, which is 3. That's the type of root. So that means cube root. Kind of a clue, because hopefully you'd recognize 27 as a cube number. I've said this before, they won't make you square root or cube root anything that's not already a square or a cube number, okay? They won't make you work out decimals or anything. So that's kind of a hint. And then the 2 at the top, you can just apply it as like a normal power, so as squared. So we need to do the cube root of 27 first and then square that answer. Then for the second one, we already touched on a negative power in like question 2 or something, didn't we? It's the reciprocal first. So in this case, a half would flip, that's plus, isn't it, to 2 over 1, which is effectively 2, isn't it? So I'll just write that as 2. And then you just apply the power as normal, so that'd be cubed. So actually I don't even need that bracket. Get rid of that. So we've got that. So cube root of 27 you should know is 3. It's not like you have to physically cube root it, you should you should just know what that answer is. 3 squared plus 2 cubed. So that's 3 squared is obviously 9. 2 cubed is 8. Add them together, we should get 17. Okay, it's literally just that. I just have to memorize the steps. Okay, question 15. An object falls from rest. Here is the distance time graph for the distance, d meters, fallen by the object t seconds after it starts to fall. So t is obviously x, distance is y. Work out an estimate for the gradient of the graph at t3. You must show how you get your answer. So in this case, when you ever have to work out an estimate of a gradient at a certain point on what is obviously clearly not a linear graph, it's a curve, it's not a straight line, you have to basically create a straight line, i.e. a tangent. We need to draw a tangent at the point t equals 3. So tangent is just a straight line that kind of touches the curve at that exact point and then carries on. Think of a tangent to a circle. It doesn't cross through, it just kind of touches, it kind of skims it and then carries on. So it's an estimate also because obviously everyone's tangent will look slightly different. So t is 3 is obviously here. Before I do that, I normally like to write down what coordinates that one actually is. You see how 3, t is 3, and then the d or the y-axis is halfway here, isn't it? Like there. So what's that scale? That's 25. If that's 25, each square is 5, isn't it? So that's 5. So that's 30, 35, 40, and then halfway. What's that, like 42.5? Not ideal numbers, but that's fine. Anyways, let's draw a tangent. So I'm going to just try and draw one where it just skims there. You see that? And then you can obviously extend it the whole way through if you want. Because what we're going to need to do is obviously equate the gradient of a straight line, we have seen already today, changing y over changing x. So I need 2 sets of coordinates. I've obviously got one. I personally like to choose the actual coordinate of where they've told me t is 3. That's, you don't have to, it's up to you. And then I'll choose one other coordinate that looks fairly easy to read off. So I feel like this one looks kind of obvious to me. That's at 5. And then 2 squares below 100. So is that 90? Well, that would be 75, 80, 85. Yeah, that would be 90, wouldn't it? That's what I'm going to choose. You can choose, obviously, any 2 that you want. I chose these 2. You could probably choose this one over here as well. Well, that would be 6.5 and then 125. But whatever you want to do, choose 2 coordinates that are obvious to you. Then we need to do change in y over change in x. Obviously, if you can, try and choose numbers that are nicer maybe than the ones I've got. So change in y, you can put whichever set of coordinates you want first, as long as you keep that the same when you do the x. So I would normally choose the bigger one, so 90 minus 42.5. And then therefore 5 would go below the 90 minus 3. Obviously I can see it should be a positive answer. So if I subtract that, that's I think 47.5. And then obviously over 2. Okay, that's not too bad actually, the one that I have to work out. I just need to half this. So half of 40 is obviously 20. Half of 7 is 3.5. And then half of a 0.5 is 0.25. They probably don't even need it this specific, to be fair. You could probably round it. So that's 23.5. 23.75 is what I got. You could probably round that to 24, to be honest. I don't think they need it to be to that many decimals because it's non-calculator. But anyway, so I got 23.75. Now, obviously, yours will be different because you'll have a different tangent and different numbers. But they have said as long as you get anywhere between 22 and 28, they'll give you the mark. Obviously, don't rub out your tangent. You have to leave it there. So as long as you've got between 22 and 28, they'll accept it. Okay? It's literally just that. Draw a tangent, work out the gradient. Okay, question 16. So, at the start of year n, the population of a species is Pn. At the start of the following year, the population of the species is given by, so they're saying this basically means the following year is equal to k times the original year, the previous year. Okay, that's what that translates to. To get the population for the following year, you take the population of the previous year and you multiply it by whatever k is. Now they've said k is a positive constant, just so we know. the population of the species at the start of year 1 is 8 million, and then the population of the species at the start of year 2 is 6 million. We have to work out the population of the species at the start of year 3. Now that entails me working out what k is. And I can work out what k is because I've been given two, like year 1 and year 2. So I can create that equation, can't I? So that Pn plus 1 is the following year, so that's the 6 million, isn't it? 6 million, you can obviously, don't have to write the zeros, you could just put an m if you want, is equal to the previous year, which was 8 million, 1, 2, 3, times by k. Do you see how now I can just work out what k is if I divide by 8 million? And then you get a nice fraction, which actually this is quite a nice one. 8 million is equal to k. If we were to simplify that, obviously, all of the zeros would cancel because they've both got 6 lots of zeros, haven't they? 6, so get rid of those. You get 6 over 8, which that simplifies to 3/4. So k is 3/4. So what they're saying is every year we're losing a quarter of the population, isn't it? And then they said work out the population of the species that start year 3. So I need to take the previous year, which is year 2. So that's 6 million. So to work out P, I guess you could call it P3, couldn't you? It's the 3rd year, is 3/4 times 6 million. So you just have to work out what is 3/4 of 6 million. So again, divide by 4 times by 3. $6 million, 2, 3, divided by 4, which is the same as halving and halving again. So that's half is 3 million, half of that is 1.5 million. 1, 2, 3. And then times by 3, you could just do 15 times 3, couldn't you? I'm going to put 1.5 million, times by 3 is basically 4.5 million, isn't it? Which because they've given their answer in terms of million, you just have to put it as 4.5, not with the zeros. Okay, that's it for part A. So k is 3/4, or as a decimal, obviously 3/4 is the same as 0.75, isn't it? So that's helpful to know for part B. They then said at the start of year 5, the value of k is increased by 0.3. That's why I've put k in terms of 0.75. So we have both decimals. I'll write it down here as well. K was originally 0.75. It's now 0.3. Well, added 0.3 to a new constant value. Louise thinks that from the start of year 5, the population of the species would increase year on year. Is Louise correct? Well, let's work out what k would be. It's effectively a multiplier, isn't it? If you think about percentages. If I add that, see how that would give me 1.05? Which, if you were to convert that into a percentage, is 105%. So if every year you've got the population is changing by 105%, is that an increase or is that a decrease? Obviously, originally it decreased because 0.75 is 75%. It's less than 100%, which means it decreased. Now, it's increasing by 5% every year. If you think about compound interest, effectively this is the same logic. It's increasing by 5%. Is Louise correct? Yes. You can write any kind of reason. It would increase by 5%. You could write k is now 1.05, anything. K is 1.05. That would probably be enough, or the population would increase by 5%. However you want to word it. Again, worded questions don't need to be that much of a complex answer, okay? You don't need to fill out all 3 lines if you don't want to. You could say that's like greater than 100% if you wanted to really spell it out. Okay, 17a, we got to factorize this quadratic. The reason why this is question 17 and not like question 6 or something is because it's a harder quadratic where you've got this number at front. So you might factorize harder quadratics. Well, you can use obviously trial and error. You can use splitting the middle term method. You might have another method. I think splitting the middle term is also known as the AC method, maybe. However you want to factorize it. I think you can do it with trial and error, but I might show you the full method for splitting the middle term if you find that might help. I wouldn't use this if it was just x squared. So 6 times minus 4 is minus 24. So we're looking for two numbers that multiply to make minus 24 and add to make, obviously, the minus 5. Oh, minus 5. So two numbers, 8 and 3, and obviously choose the symbols whilst you're here. To make minus 5, I would have to take minus 8 and I'd have to add 3, wouldn't I? So that's the same here. Minus 8 times 3 would make minus 24. Then what we do is we rewrite the quadratic, but you split the middle term, as in this one, into minus 8x plus 3x. Doesn't matter which order you put them in, actually. You can put them in whichever order you like. So let's say 6x squared minus 8x plus 3x. I've split that middle term. Do you see how if I were to simplify that, I would still get the same again? So it's the same exact quadratic. I haven't changed it technically apart from the formatting. Then what you want to do is just factorize into single brackets the first half and the second half. So as in, what can I pull out as a common factor here? Well, in terms of 6 and 8, I could pull out 2, couldn't I? Oh, and then I could also pull out an x, 2x. And then inside the bracket, I'd have to put 3x minus 4. That's the first one. The second one, I actually can't pull out anything, can I? As in, well, I have to pull out a 1, but there's nothing in common apart from 1. So pull out 1, and then you see how you get 3x minus 4. You'll know if you're correct if both of these brackets are identical, not only in terms of numbers, letters, but also symbols. So that has to be a plus in order to make that true. And then your two brackets, obviously one of them is 3x minus 4, and then the other one, get a different colour, is whatever's on the outside. So I would have 3x minus 4, and then, what is that, 2x plus 1. Okay, that's the splitting middle term method. You can use that method, or you can do trial and error. Completely up to you, whatever makes sense to you. Part B, they've said, hence or otherwise, solve this inequality, which is exactly the same quadratic, but now it's in an inequality form. So, or otherwise, I'd probably use hence. I'd probably use based on that previous answer. So solving quadratics, we normally step 1 is trying, or option 1 is trying to factorize. There are other options like quadratic formula, completing the square, things like that. But normally you try and factorize. In this case, we've already proven that we can factorize it, so that's why I'm going to use my previous answer. Now, I like to just put it equal to 0 for now, and then I'll bring the inequality back at the end. So I'll solve it based on just being an equation equal to 0. This is the same as this, isn't it? Just a different format. So solving it, I need to get x is 4 over 3 for the first bracket, or x is minus a half for the second bracket. Okay, hopefully you know how to solve quadratics from there. Then obviously I need to bring back in the fact that I've got an inequality. Now you can just memorize, because solving quadratic inequalities, there's only two possible formats for the answer. Either the x is between those two numbers, so it's a range, or x is, there's two different inequalities, x is smaller than the smallest answer, or bigger than the biggest answer. Those are the two possibilities. And it all depends on obviously which way the symbol faces. So you could just memorize which way it faces. So if it faces 0, then it is the range. If it faces the other way, so if it faces the quadratic, it's the two separate answers. So you can just memorize that. So nice, this one's quite easy because it faces 0. Obviously make sure you put the smallest answer on the left, which is negative a half, x in the middle, and then the biggest answer on the right. Okay, that would be then your final answer. X is between negative a half and 4/3. Okay, question 18. Spinner A and spinner B are each spun once. The probability that spinner A lands on red is a quarter. The probability that both spinner A and spinner B land on red is 1/24. Work out the probability that one spinner lands on red and the other does not land on red. So it's either red or not red, isn't it? This one, because there's two spinners, and obviously each one is spun once, that's like 2 events. It's making me think probability tree, so I would like to draw that out. You don't have to necessarily draw it if you can visualize it yourself, but I like to draw out a tree. So this one will be for spinner A, right? Which it's either red or it's not red, isn't it? Let's just put those 2 options. We don't know what colours are there other than red. So obviously red for spinner A is a quarter. We can write that in. And then the other one is spinner B. Again, red, not red. This one must be obviously therefore 3/4 because that has to add up to 1. And then red, not red. Now we don't know the probability for red, do we? For spinner B. What we do know is A and B being red. So if I get my highlighter, I like to highlight the things on probability trees. If I follow that route, it would be red A, red B. Now think about how you work out, how you do calculations in a probability tree. Between the branches, we always multiply, don't we? So what they would have done is they would have done 1/4 multiplied by whatever the probability of red, the spinner B is, and they would get 1/24. So if we just call that X for now. Do you see how they would have done 1/4 multiplied by X equals 1/24? And I've created an equation there. Now I can work out how to reverse that equation. That's obviously write it without that multiplication symbol. 1/4 X is equal to 1/24. So to find out what X is, you can either divide by a quarter, you could do keep flip change if you like. I would probably just multiply by the denominator, which is 4. So multiply across by 4, obviously that leaves 1x, which is fine. When you're multiplying by a whole number, it goes into the numerator, so that's 4/24. And then let's just simplify that whilst we're here. That would be 1/6, wouldn't it? So the probability of red for B is 1/6. So I can come back now because they've also asked me something else beyond just working that out. If that's 1/6, then not red for B would be 5/6, wouldn't it? Again, that has to add up to 1. So I've completed my probability tree. Now let's actually go back to what the question was asking. Work out the probability that one spinner lands on red and the other spinner does not. So I need to get rid of my original highlights. Then we can re-highlight some options. So highlight all the options that satisfy what they've asked. They've said one lands on red, one doesn't. So it could be red for A, but then it would have to be not red for B. Or it could be not red for A, and then it would have to be red for B. Those are the 2 possibilities, aren't they? And now we just use our probability tree as normal. So you normally multiply across. So red A, not red B would be 1/4 times by 5/6, which is 5/24. And then not red A times red B is 3/4 times by 1/6, which is 3/24. And then when you have multiple options, you see how we've got a blue option or a green option, that's when you have to add them, isn't it? So luckily, because we've not simplified anything, we've just left them as they are. They have already got the same denominator, so we just add the numerators, which is 8/24. So you can leave your answer as 8/24, or that does technically simplify to 1/3, doesn't it? It doesn't really matter, they'll accept either. They haven't told you to simplify it, so they will accept either. 1/3. Okay, question 19. Here is the graph of y equals sine x for obviously the range minus 180 to 180. Use the graph to find estimates for the solutions of sine x equals 0.3 for that same range. This overlaps a little bit with A-level, I guess. Well, at least you get a better idea or a better understanding of it in A-level. What I would say for GCSE is look at the original equation, as in this, and compare it to what they've then given you. Apart from the fact that it's obviously swapped left to right, ignore that. Apart from that, do you see how the only thing that's different is where y used to be, there's now a 0.3? The sine x is still the same, it's just obviously on the left instead of the right. So what that's saying is where y is equal to 0.3. So this you might have seen in other questions where it's just a quadratic or, yeah, normally a quadratic. where they put the quadratic equal to 0 or equal to a number, and you have to use the graph to solve it. This is exactly the same logic. Okay, I know you can't obviously do sine inverse because you don't have a calculator, so you're going to use the graph. So I'm going to need to draw a line for y equals 0.3, which is a horizontal line. So if you just make sure you obviously get it accurate, make sure you've got the scale. 0.3 is here, isn't it? Draw a line all the way across. It said find estimates for the solutions, as in there's multiple solutions, which you can see because you see how where our line, y equals 0.3, crosses that sine graph in two places. So that's the two solutions, isn't it? I don't know if we should maybe zoom in a bit. Let's zoom in a bit just so you can see. And we just have to figure out, make my line a bit more accurate. There's one here, isn't there, roughly? And then there's one here. I might redraw that line. It's a bit thick, isn't it? I don't know how accurate that's going to be. I think they do give you a slight range because obviously it's hard to see it, isn't it? Where's 0.3? Here. There. Okay, let me redraw my other lines. It should be symmetrical though, to be fair. Okay, I guess it almost touches this line here, doesn't it? So square here almost there, and then yeah, it's just slightly after. I know it looks like I've drawn it on that line, but it's slightly before and slightly after, isn't it? So let's look at the scale. We've got 90 here, and then there's 3 squares, so that's obviously 30, isn't it? That's obviously 60. And then it's almost 3/5 of the way, but a bit less, not quite halfway. Halfway would be 15, so it's somewhere between 15 and 20 is what I would say. Somewhere between 15 and 20. So, I mean, my guess is like 18 or 19 for that first one. So x is, let's just write 18. And then over here, you can either, because it's symmetrical around this point here, it's a really horrible line, let me draw a straight line there. This is the line of symmetry for at least the right-hand side of the graph, isn't it? So what you could do is 180 minus the 18, or you can obviously try and read it off. Up to you. So that's 90, that's 120, this is 150 here, isn't it? 120, 150, it's not quite halfway, so that, what would that be? That would be 165, a bit less than 165, somewhere between 160 and 165, I guess, isn't it? So I'm going to use my 18, I would do 180 minus 18, which is 162. That's what I would do. You could put 15 and 165, that's also fine. It's not super obvious, is it? Let's zoom out. So those are the solutions, because we already know what y is. Y is 0.3, you don't need to write down y, you just need to write down the solutions for x. So that would be your answer there. Now they have said you can put anything between 15 and 180, 15 and 18, and 162 and 165, which isn't a massive range to be honest, but that's your range. If you've got anything between those two ranges, you'll be fine. Okay, and then part B, this is even more so towards A level, I would say, to be honest. Write down a value, so just one, of x such that sine x plus 20 is equal to 0. So what I would do in terms of GCSE, in terms of your knowledge with GCSE, is that's a graph transformation, isn't it? Just looking at the left-hand side, that's a graph transformation. It's a translation, so moving up and down left to right. It's next to the x, so it's an x-axis one, but remember x-axis is always the wrong way, isn't it? So it's actually a minus 20. Imagine all of those x coordinates have shifted by 20 to the left. So what you could do if you wanted is you could draw that on, if you found that helpful. So what I might do is rub out this, if you obviously take a screenshot of the original if you want to know part A, but I'm going to rub this out for now. Delete all of this. So yeah, think of your graph transformations. Zoom in again. And just move everything, as in all of the main coordinates, 20 to the left, minus 20. So remember our scale, that's like minus 30, isn't it there? So the 0 would go, what, 2? minus 6, 12, 18. So it's roughly here, isn't it? Somewhere there. This is just rough. 90 minus 20 is 70. We know that this is 60. About here. This one, which was 180. That was 150, wasn't it? So it would be 160, wouldn't it? About here. And then this one. Out here, you can kind of see the amount of the square that they moved by. This one probably about here. This is going to be a horrible line, but obviously you'd be able to draw it better than I can. Okay, that's really bad. But do you see how it's all shifted 20 degrees to the left, basically? So now let's go back to what the equation actually said. That's the left-hand side, isn't it? They've said it equals to 0. Think about the original where we said what was on this other side. That one represents y, where y is 0. Okay, the line y is 0 is obviously the x-axis, isn't it? So what they're saying is, where does this new translated curve cross y equals 0? Well, you've got this option, and you've got this option, and technically there's this option, but do you see how the range is still between minus 180 and 180? That's now outside the range, isn't it? So not that one. So they've said write down a value because they're suggesting that there's obviously a couple you could choose from. There's 2 here that we can choose from. You just have to choose whichever one. So we said we've basically taken everything and subtracted 20, haven't we? Do you see how that one's 180 minus 20? And this one here is 0 minus 20. So you could either write down negative 20 or 160. One of those 2 answers is fine, whichever you prefer. Okay, let's maybe go with 160. Doesn't matter. Minus 20 or 160. They've only asked for 1, so just put 1. Okay, it's kind of a hard one because you're having to overlap the logic of graph transformations, what that does, how that affects the coordinates, and then also where am I looking on the graph, where y was 0 in this case. Okay, question 20. So here is triangle ABC. Find the size of angle ABC. So angle ABC is this one. Put X there for now. It's a scalene triangle. We've got some sides. We want to work out an angle. It's going to be something to do with trig. It's not SOHCAHTOA, obviously, because it's not a right angle. Scalene triangle. But the other version of trig is then sine or cosine rule. So that's kind of what I go through in my head. Process of elimination. It's either sine or cosine rule. Now, sine rule is 2 pairs, isn't it? 2 pairs of angles, 2 pairs of sides, obviously including the one you want to find out. In this case, we don't have 2 pairs. Cosine rule is 3 sides, 1 angle. Do you see how that's exactly cosine rule? So I'm going to use cosine rule, which is obviously on your formula sheet, but I can write it here. A squared is b squared plus c squared minus 2bc cos a. Now, the thing is, though, we're looking for an angle. So either I don't think they put the angle version on the formula sheet, so you either have to memorize the angle version or you have to rearrange this one. Because we want to obviously find the angle. So we could rearrange it. So what I do to rearrange is I add the 2bc cos a to make it positive, because obviously I want positive cos a ultimately. Cos a. And then I subtract a squared, so I effectively swap them. The b squared, c squared can stay where it is. Minus a squared, and then just divide by 2bc to get rid of that from the left. So you get b squared plus c squared minus a squared over 2bc. So that's the formula I'm going to use. Now we want to label our sides. Now obviously cosine rule is based in terms of the angle A. Here we've got angle B, so what I personally like to do is just rewrite, like I make it match so that I don't get all of my sides mixed up. That has to be angle A, so that has to be side A. C can stay where it is, but that was originally B, so now this one has to become B. Side B. Okay, you can just rewrite the letters, that's fine. Now we sub it all in, so cos of the angle X is 5 squared plus 10 squared minus 5 root 7, put that in brackets, squared. We've obviously got surds here. over 2, 5, 10. And we just need to basically simplify this fraction and hopefully we'll recognise what we get at the end. So I think what I'll do is I'll rub out all of this rearranging first. And then we can have some more space to work it out. Okay, so obviously keep your cos x there. We get 25 plus 100, and then minus, we're squaring both, basically square these separately, so that's obviously 25, and then root 7 squared is obviously either root 49, which becomes 7, or just straight away 7. Over 2 times 5 is 10, times 10 is 100. And then we'll simplify the numerator. So we get 125, and then 7 times 25, you can obviously... I personally did 8 times 25 because I know that's 200 and I minused 1, but we can obviously do it, you know, multiplication, column multiplication. So 7 times 5 is 35, so 5 carry the 3. 7 times 2 is 14, plus 3 is 17, 175. So we've got 125 minus 175 is minus 50 over 100. And then that simplifies to negative a half. Okay, which again, remember, is cos of the angle x. Now we can't do cos inverse, literally, because we don't have a calculator. But this is where we need to kind of try and remember what you would get on your table. Now I know it's not negative a half, that's the other thing we need to consider. But hopefully you know what cos of a half is. So cos of a half, I'll write that over here. Cos of a half is 60. Oh, sorry. Cos of a half, x would be 60. But because we've got negative a half, again, this feels like we're leaking quite far into A level, really. The way that I guess I would maybe look at it is using the cos graph, which we should obviously know. 1 minus 1 starts at 1, doesn't it? Down, up. Technically it goes negative as well. 90. Same as the sine graph, really, just obviously you've just shifted it a bit along. 180, 270, that one there's 360 at the top. What we're saying is minus a half. So again, think of this again as like this side is equal to y in terms of the graph. So if I were to draw a line, if I get a line, make it orange, shall we? Yeah. Minus a half, I mean, I know I've obviously sketched this very roughly, is like, let's say there. We want to know what this one is. Okay. And the way that I can use the 60 to help me, because obviously my scale there is, I know it's somewhere between 90 and 180, but that's not very accurate, is it? Is you just do the 180, because you see how we're 180 in this case is where we've got our line of symmetry. You just have to do 180 minus 60. So 180 minus 60 gives you 120. It's actually 120 degrees. So that one's, yeah, a little bit harder. I mean, there's obviously different ways to figure out how to go from the 60 to the 120. You might have a different way of looking at it. That's absolutely fine. Whatever way makes sense to you. There's loads of different ways. But yeah, I feel like you can kind of get to this minus a half bit first, but it's a little bit hard to figure out where to go from there. Okay, question 21a. On the grid, draw the graph of x squared plus y squared is 169. You should recognize that as a circle graph, but also what number we need. Well, this is equal to the radius. squared, isn't it? So therefore, the radius, write it properly, radius is the square root of 169. Again, they won't make you square root something that's not already a square number, so hopefully you recognize that as 13 squared is 169. So I need to just, in your case, you'd obviously get your compass, put the point on 0 and measure it to 13, which is like up here somewhere, and then just draw a circle with your pencil. I'm just obviously going to get my circle shape and do it that way. So, about that, isn't it? About there, roughly. It should be halfway between 12 and 14. So that's part A, literally. Just as long as you draw a circle, radius 13. Then part B, use your graph to find estimates for the solutions of the simultaneous equations. Obviously, the first one is the exact same, so we've already drawn that. The second one, if you can see, is a straight line graph. And I know that because there's nothing squared, it's just literally y and x. It's a straight line, linear. So what I will need to do is plot this straight line. So personally, I like to make it in terms of y, so I'm just going to divide both sides by 2, so you get 3 over 2x, and then you need, as we said before, when we've obviously drawn other lines, you need 2 sets of coordinates. The first one I tend to do is the y-intercept, which, you see how this one doesn't have a plus c, which means the y-intercept is just literally 0. So that's easy. And then I'll just choose another x value on my graph that hopefully would still not be too big. So maybe like, maybe 6. So when, you can choose any, but when x is 6, y is 3 over 2 times 6, you'd obviously have to work that out. 3 times 6 is 18, divided by 2 is 9. So my second set of coordinates is 6 and then 9. 6 and then try and get this accurate. Halfway there, isn't it? And then obviously get your ruler, draw a straight line between them, but carry it on the whole way through the graph. Extend it the whole way. Like that, and then I'll carry it on. There. Because they've said use the graph. So solving simultaneous equations graphically is just by seeing where they overlap, where they intersect. So we've obviously got one intersection up here. Try and draw a line. We want to work out x and y because we don't technically know x and y. When you do simultaneous equations, you need both x and y, don't you? I'm going to go down and across. So reading that off, that looks to me, be careful of the scale because you might think that's 6.6, but it's not because this here halfway through, 7, isn't it? So I don't know, maybe 7.2, my guess. Not enough space there, is it? X is 7.2 for that one. And then y for that same one across is, I don't know, like 10.8. Again, be careful of the scale, that's not quite more than 11, is it? And then on the other side, which hopefully it's kind of symmetrical because obviously the circle is center 0, 0, but cross, and then just depends how accurately you've drawn your circle and your line, I guess. Up. See, that looks slightly different. I feel like it should be the same, it should be symmetrical, but mine obviously looks slightly different because I didn't necessarily draw my circle too accurately. That looks exactly like -7, doesn't it? It shouldn't be, it should obviously be symmetrical, but just the negative version. But I'm just going to write what I can see, but it should be the same. -7, and then y is, don't forget to put the negative if there's a negative. That looks like -11, which again I think should be -10.8, but anyway. That's what I've got, and that would be it. That's literally 3 marks. If I need to scroll that up a bit. 3 marks. Now, again, because your circle, your straight line will look, I mean, they shouldn't be too far off, but they might be slightly different for everyone. They have given a range of possible answers. So as long as you got between, write it over here, this is the same for the negative. X between 7 and 7.4, they'll allow it. Obviously, I think the actual answer is 7.2, but anyway. As long as you get between 7 and 7.4, and obviously the negative version of that, so negative 7, negative 7.4, that's fine. And Y was between 10.6 and 11. Again, positive, negative. I think the actual answer is technically 10.8 and negative 10.8. As long as you get somewhere between those ranges, you'll get all the marks. Okay, so we're on our last question now. Looks like we've got some surds here, and sequences actually. So, question 22. The second term of a geometric sequence is 3 plus 2 root 2. The third term of the sequence is 13 plus 9 root 2. Find the value of the common ratio of the sequence. Give your answer in the form a plus root b, where a and b are integers. Now, yeah, we're combining two topics here. So we need to know about geometric sequences. We need to know the formula for that, basically, don't we? A geometric sequence, first of all, we need to know what that is where the difference between each term is actually a multiplication. So you've taken term number 1 and then you've multiplied it by, I don't know, just a number. And in the second term, you multiply that by the same thing again, and then the same thing again, and the same thing, but it's multiplication. That's what I mean by geometric sequences. So we would want to know, well, obviously they've asked us to find the common ratio, which is that thing you're multiplying by, isn't it? So all of them start with a starting number. We don't have the starting term, obviously, because they've given us the second term. Then it would have been multiplied by the common ratio to get this term, the second term. And then it would have been multiplied again by that same ratio, or that same value, to get the third term. So we want to find that R. We normally use AR. I don't know if you've seen that, or if that's more A level. A is the starting term, and then to get term 2, you would have multiplied by R. So you see how AR would be the same as this 3 plus 2 root 2. 3 there. And then the third term would be AR times by another R. So you see that would be AR squared, which is 13 plus 9 root 2. We've effectively got simultaneous equations because we've got two letters, A and R. Now, we actually want to know the common ratio, which is R. We don't really care what A is. Okay, so in this case, it's kind of simultaneous equations, but you're not really bothered about what one of the letters is. So in this case, probably what I would probably do is I think I would divide. I think, yeah, you could... Can't really use elimination or well, you can't use elimination because it's not a linear one, right? You've got R squared. So I guess it's substitution really, isn't it? That you would need. So what I think I would do is replace the A. Let's rearrange this one to make A the subject, which is obviously just divide by R. And then if I substitute that in, you see how I would get 3 plus 2 root 2 over R. And then it's multiplied by R squared equals obviously the 13 plus 9 root 2. So I've got rid of A because I actually don't care what A is. I just need to know what R is. Now we're just solving this. So if I were to write this as a single fraction, the R squared goes in the numerator, doesn't it? Only the numerator, because it's technically, as always, R over 1. And then you see how we could cancel out, like that would divide. And then this would cancel, so you'd be left with just an R in the numerator, which is equal, obviously, to this other one here, 13 plus 9 root 2. So let me rewrite that. We've been left with r multiplied by 3 plus 2 root 2 equals 13 plus 9 root 2. I wouldn't expand that because I would just directly divide by this whole bracket because I want to know what r is. So you get 13 plus 9 root 2 over 3 plus 2 root 9. That's one way of doing it. I mean, I guess you could just divide it straight away, couldn't you? Because you know that the common ratios are. That's probably a more direct way of doing it than using simultaneous equations. It just depends how your brain processes it. You can just divide it to find the common ratio straight away if this doesn't make sense. Now, what I would need to do there, though, is to see how they've said give your answer in the form a plus root b. So that's clearly not what I've got here. So we rub all this out. R is that. Now we're kind of more focused on the surds as such. How do I deal with this fraction? Well, when I've got a fraction with surds, and particularly when the surd is in the denominator, that's when I'm thinking, okay, the only thing I can really do is rationalize. Okay, whenever you see surds and a fraction, it's normally something to do with rationalizing. So rationalizing a denominator, especially when here, do you see how I've got two terms, like 3 and the 2 root 2? I need to multiply by the same thing, except I need to change the symbol. So it'd be multiplied by 3 minus 2 root 2. Obviously, because it's a fraction, I have to do the same to the top and the bottom. So then I end up with these double brackets, effectively, isn't it? 13 plus 9 root 2 at the top, multiplied by 3. Just, you don't have to necessarily write it out like this, but I'm just kind of over-explaining everything. 3 plus 2 root 2, 3 minus 2 root 2. Hopefully at the bottom you can notice that that's effectively going to be a difference to 2 squares situation. And then we just need to expand everything. So expanding double brackets, you obviously need to be okay with surd rules as well. 13 times 3 is 39. 13 times negative 2 root 2. Obviously the 13 is a whole number, so it's only going to affect the number on the outside. So that'd be 26 root 2. Then plus 27 root 2 again. That's only affecting the numbers on the outside. There's no other surds there to multiply with the root 2. And then a minus. Multiply the numbers on the outside, which is 18, and then root 2 times root 2 is obviously 2, or root 4, whichever one you want to write down. That's the numerator. Denominator, I'm going to expand it fully, but you might already know what this is going to end up being. That's 9 minus 6 root 2 plus 6 root 2. That's why the plus and a minus is really important. You want one of each, because we're trying to cancel out those surds in the denominator, aren't we? And then, be careful here, that's obviously a negative. 2 times 2 on the outside is 4, and then root 2 times root 2 is 2. Okay, let me scroll down again so we can keep simplifying. So the numerator, we've got 39 minus, and then obviously 18 times 2 is 36, so that would be 3, wouldn't it? And then negative 26 root 2 plus 27 root 2, well, because they're both root 2s, I can actually add them, so that would just be plus root 2, wouldn't it? Now the bottom, the whole point of doing a plus and a minus is obviously that there's still surds here, but they cancel each other out, because it's the same amount, but plus and a minus, so they're not there anymore. And you get 9 minus 4 times 2 is 8. 9 minus 8, oh, that's my black. 9 minus 8 is 1. So therefore, you see how obviously that is no longer a fraction, so you don't need to write the 1. So that's the format they wanted, 3 plus root 2. So we had to also then use surds to get this format, a plus root b. Okay, normally surds is right at the end, and sometimes it can be combined with another topic. As I said, you don't necessarily have to do these simultaneous equations. I just wrote it out so you could see, well, first of all, one way of doing it, but also so you could kind of see what the difference between them was. In order to find the common ratio, you just need to divide them straight away. If it's obviously the consecutive terms, second and third. The difference is just r. So you can just divide those straight away. That's also fine. Whichever way makes sense to you. Literally, a lot of these, as I said, we've gone through this paper and I've kind of given you two options for a lot of the different questions. It just depends which way your head kind of goes and which one makes more sense to you, because whatever makes sense to me might not make sense to you. It might be the other option, which is also fine. So that is everything on the November 2023 paper 1, obviously higher tier Edexcel. We will be going through on Wednesday and Thursday we'll be going through paper 2 and paper 3 of this same November 2023 series. So if you want to obviously complete those, feel free to come at the same time, 7 o'clock, Wednesday and Thursday. Last week we went through June 2023, paper obviously 1 to 3. So those lives are just uploaded to my channel. If you want to go through those, you can look back at them as well. And just make sure that you have your scientific calculator ready for Wednesday and Thursday, because obviously those will be calculator ones.